right, now we've got a cost example. We've got a speed of a car in meters per second. For velocity greater than 5, the cost per kilometer, so per kilometer, is C pence. And pence is like cents, but in the UK, so it's a unit of money. So we've got cost. Show by calculus there's a value V for which the cost has a stationary value. So stationary values, remember, we have a stationary point when our derivative, so in this case our derivative is going to be dc dv, is 0. So let's start by finding dc dv. So first c is 140 v to the negative 1 plus 1 over 4900 v squared. So when I take out my number in front, it's 1 over the 4900. dc dv, negative 140 v to the negative 2 plus 2 over 4900 v to the power 1. Now I'm going to set that equal to 0. So negative 140 over v squared, v to the negative 2 is over v squared, plus 2v over 4900 equals 0. Let's put this in our calculator. So we've got negative 140 over v squared plus 2v over 4900. I don't know what this looks like, so I'll just start with a normal window. All right, so I want it to be equal to 0. And we don't see it equal to 0 yet. So I'm going to change my window and add more x values. I definitely don't need any more y values. I'm looking at a velocity, and already it tells me my velocity is bigger than 5. So I'm going to start at 5, and now I'm going to go up to a velocity of 100. So we can definitely have a velocity of 100 kilometers per hour. I'm going to go back to my graph. I should not have counted by ones, clearly. All right, so presumably somewhere along here I'm crossing the axis. If I want to make sure, I can go into my table. So I'm going to look at my table of values. I'm going to start at 5, and I'm going to count by 5s. So I want to make sure that I'm crossing the x-axis. So I go from negative values, and hopefully at some point they become positive. So all of these are negative and negative. Here I've got 0, and then it becomes positive. So I can see just from my table of values that I must cross at v equals 70. Okay, so that's one way to solve it. I could have used my calc 0 function. So based on my picture here, it's hard to see where it happens. I know for sure it's negative over here. So I could say that my left bound was like 10. And it's hard to see where it crosses on the right. So I could say my right bound is 90. And my guess, based on this, I can't really see. So my guess I would say is 50. But I also get 70. So I could have done it with my graph as well. To justify that it's a minimum, well, this is just like the problem before. So for v less than 70, my derivative value is negative. So v is decreasing. For v bigger than 70, my derivative is positive. So v is increasing. And I see that in my graph again. I have negative values and then positive values. They're really small numbers though, so it's hard for me to see with this big scale. But I looked at the table, I saw negative numbers and then positive numbers. So the function has a min at v equals 70. So again, if I go from decreasing to increasing means we had a minimum turning point. Find the minimum value of c. So I found the v value, so that's 70 meters per second. So my cost then is going to be 140 over 70 plus 70 squared over 4,900. Well, 140 over 70 plus 70 squared over 4,900. I get 3. So this means I've got a cost of 3 pence. And what was my units? So cost per kilometer in pence is using this function. So my cost is 3 pence per kilometer at a speed of 70 meters per second. Hence, if we go 300 kilometers at this speed, we have a cost of 3 times 300, which is 900 pence. And that's the same as 9 pounds. You don't need to know those currency conversions, but there you go.